Before Johannes Walter, in 1870, two Russians, Golofkinsky and Inolstrantsiev, had noticed that in ancient ocean basins that had filled up with sediment, the same series of deposits could be seen on the surface side by side and vertically, one underneath the other. The feature of these series of deposits or facies are that they are parallel to the basin slope. Those in the Gulf of Naples, observed by Walter, are not. They are almost horizontal. The reason is that apart from small changes caused by the tides, the series of deposits in the Gulf of Naples and elsewhere result from the sea always being at the same level. The position of deposits of sediments in ocean basins, such as those observed by the two Russian scientists, would seem to be the result of major changes in the level of the ocean. Rising water level is called a transgression. Falling water level is called a regression. When the water rises or transgresses, perhaps as the result of tidal waves, the sediments deposit parallel to the sloping sides of the ocean basin. The larger yellow particles depositing next to the slope. When the water level falls or regresses, the sediments deposit with the smallest particles, colored orange, next to the slope. Looking at former ocean basins, now filled in with sediments, the position of the deposits or facies indicate that the waters of the past must have risen and fallen time after time in fast succession. As sedimentologists would say, transgressions followed by regressions seem to have occurred in cycles. The different kinds of deposit are again the result of sediment sorting itself out sideways, and not one type of deposit superposing itself upon another. It would appear, therefore, that the origin of sedimentary basins is the result of cycles of fast, rising and falling water levels, or more technically, transgressions and regressions. The position of the deposits is not, therefore, the result of the principles of superposition and continuity, but the application of the law of Johannes Walter. These cycles of rising and falling water levels couldn't have taken place all around the world at the same time. Perhaps they were like large-scale ocean tides, so that where the water level was rising and depositing massive sediments in one place, at the same time sediments were being deposited elsewhere, where the water level was dropping.
The reaction of the other rock experts was that Johannes Walter's discovery only explained coastal rocks, and that deep sea sediments were always formed by a layer of sediment forming on top of another, and that the layer on top is always younger than the layer underneath. In this cliff face, probably formed from deep sea sediments, the strata in the banks at the bottom are believed to be much older than the strata up there in the top. The reason for this is that geologists believe that strata and layers are the same thing.
In the 1970s and 80s, several holes bored into the bottom of the Pacific Ocean by the Glomar Challenger vessel produced samples of sediment that showed Walter's discovery applied to the deep sea sediments just as well as coastal sediments. This meant that virtually all sedimentary rock formations in the world must have been formed in the same way.
So what does all this mean? Well, take what is considered to be the biggest, the widest, the deepest, the longest canyon in the world, the Grand Canyon in the United States. The sides of the canyon display banks, one on top of the other, from the bottom of the mile-deep canyon to the top. Each bank is said to indicate an age in geological time. Yet, what we know from Johannes Walter's discovery and the Glomar Challenger deep-sea borings indicates that parts of different banks could be the same age. Nevertheless, there were still those who found this difficult to accept. But two recent events have occurred, however, which should remove all further doubts.
In 1980, Mount St. Helens, a volcano in the United States, exploded. It flattened an extensive forest and caused a tidal wave in a large local lake. Within hours, 600 feet of sediment had formed, which dried into rocks complete with strata. As a result of the explosion, huge amounts of mud flowed through the adjacent rocks and bored a canyon over 100 feet deep and 200 feet wide.
Now, it has always been believed that strata in rocks and canyons take millions of years to form. But both these geological formations were formed within several hours.
The other event took place in a laboratory. French sedimentologist Guy Berthaud discovered two immensely important facts. The first was that sand, flowing continuously, whether in a vacuum, in the air, or in the water, sorts itself out into alternating deposits of large and small particles that look like layers, but are not layers. The second vital fact emerged during the program of experiments he was directing with the State University of Colorado. Looking through the transparent sides of a large tank or flume, he studied the particles of sediment in the moving water. He observed that when the speed of the current was reduced, only the large particles of sediment were deposited. When the current was increased, microstrata started to form. So the grading of particles in strata was not just the result of layers of sediment piling up on top of each other, as had always been thought. The grading could simply be due to variations in the speed of the current when the particles were deposited. A further startling discovery was that joints or breaks between strata are the result of desiccation or drying out of sediment. It used to be thought that these joints were caused by an interruption in the supply of sediment. It was thought that the surface of the last deposited strata had hardened, and that many years later, new sediments started to fall, and a new strata formed on top of the old one. This theory now has to be abandoned because of two new discoveries. The first was that the underwater borings of Glomar Challenger showed that surface sediments under the sea never harden. In fact, hardening of sediments only starts 300 meters below the seabed. The only known exception is chert sediments, which even so only start hardening 100 meters below the sea bottom. The second discovery was in the laboratory. It was found that when the sea level drops and the damp sediments are exposed to the air, breaks occur between some of the strata as part of the drying out process. So these joints or breaks have nothing to do with time. These experiments, performed by a team of experts over many months under the most rigorous laboratory conditions, have been filmed and are available for all to see. They confirm the most important fact ever discovered in the history of sedimentology. Strata provide no indication of age. Guy Berthaud has shown that the strata you see in these banks are caused by changes in water currents. They don't just deposit themselves one upon the other over vast periods of time. They form sideways in a crab-like fashion, just like the banks. These experiments were then performed on a larger scale and presented to the 14th International Congress of Sedimentology in the following documentary film,